We're on the clock. We're live.
All right, very good. Go. Hi, everybody. Welcome to another episode of Continuous Discussions, the online forum where we talk about Agile, DevOps, continuous integration, and continuous delivery. I'm Sam Fell.
And I'm Anders Walgren, and today's topic is CI acceleration. We're going to be talking about some of the tips and tricks that we use to accelerate our CI cycles to improve developer productivity, and talk about how to speed up build and test times, how to, more importantly, ensure accurate builds and consistent tests at scale, and how to better utilize your CI infrastructure and get stuff done. And as usual, we've got a distinguished set of panelists that we will now introduce.
Wonderful. So first and foremost, we have Eric Melski back on the program. Eric, can you introduce yourself?
Sure. My name is Eric Melski. I'm one of the founders of Electric Cloud and now Chief Architect for the Electric Accelerator as well.
Wonderful. Thank you for joining us again. Irfan, introduce yourself.
Hey, how are you? I'm Irfan. I'm here as a DevOps architect for the different cloud-based application and the on-premise solutions. And I'm working here as a DevOps end-to-end solution and all for the products.
Wonderful. Well, welcome to the program. Nirav.
Hey, I'm Nirav and working as General Manager of Technology and Solutions. And we help people develop their automation scripts and automation tools. Thank you.
Wonderful. Great. Spencer.
Hey, I'm Spencer Allen from BTI 360 and do a lot of DevOps, building anything with automation tools, especially Gradle, Jenkins, you name it, old school, new school, whatever we can get to get developer time down.
Nice. Or get innovation time up and developer chore time down. Got it. All right. And Vishnu.
Hi everyone, this is Vishnu and I'm founder of AutoRabbit. It's a continuous delivery tool or a continuous delivery product for several technologies, but we are mainly focusing on Salesforce.com because that's one of the areas or one of the technologies where CI is very, very mature as a process in the ecosystem.
Wonderful. Well, welcome. Welcome to everybody. Thank you all for joining us. We are sort of going back to, not all the way to the beginning with Agile, but we are going back pretty far into this whole DevOps continuous delivery cycle to talk about continuous integration. And so let's sort of start with what, can you guys see my screen or no?
Okay.
Wonderful. All right, great. Yes, I know you can because you're sitting right here. That was good. So let's start with how do you define continuous integration, right? Fowler obviously has his opinion on it. I think that that's probably a pretty well established one and people pretty much agree with it. But let's go in a little bit deeper and find out how folks in the audience or on the panel here are thinking about it. What is your sort of personal opinion on CI? And I'm going to start with Eric.
You're going to start with Eric.
I'm starting with you.
Can I defer to somebody else?
Let's start with Irfan.
Right.
That's what I meant to say. You are muted. We muted you because there was background noise. So
Okay.
there you go.
Now it's audible? Yeah. Okay, so from my perspective, the continuous integration is a process where we continuously integrate the code base and then make the specific code base in the more stable and the reliable manner, where we can have more robust kind of product builds and get going stuff, so that we can have more reliability, confidence on the applications which we are going to build, and make the entire product released to market as quickly as possible. So CI is basically like is a process where we can have continuously integrate the check-in processes, make the more code stable, and make sure that we have all the sanity test cases up and running, and then make the actual code base on a specific area is more robust and all. So that is what I feel that continuous integration will give the entire application as a one higher level of more maturity, productivity, and it will if anything is wrong on the specific side, which we can have more easy way to rectify that problem and get going further. So that is what I feel as a part of our CI stuff.
Great. Thanks, Irfan. Nirav, what are your thoughts on this?
Well, it is a definition of done for developers, and I think no one has said this ever. It is not only the definition of done for developers because it is just halfway through. Like if I'm a developer and if I keep on committing my code towards the end of sprint, uh, I'll end up probably, or the team will end up probably getting errors to the late. So the meaning and objective for CI would be to catch errors as early as possible in the cycle of SDLC. So to me, it is not just the continuous integration, it is also the continuous improvement and continuous introspection. Like we keep on committing code, whatever we do, probably say every half an hour, every hour, or every 2 hours, based on the size of the project, the phase of project, and the mode of delivery. Like we keep on doing intermediate commits and we try and catch the errors as early as possible. So if we have a lot of automation done at unit testing level, integration testing level, and regression testing level, we would have better idea of catching errors as early as possible, and we can justify the time, quality, and the cost for the project. So that is all about CI in my perspective as a pre-step for the CD.
I love it. I think that the whole idea of getting feedback faster, pushing all that work to the left, right?
Yeah.
Shift left, as they say. It's a lot cheaper to solve those problems earlier when it still sort of hasn't been swapped out of core memory for the developer. It's very important. Those are great points. Thanks, Nirav.
Yeah.
Spencer, what are your thoughts?
Total agreement with Nirav there. Fail early, fail fast, fast as you can. You want to get to your cycle time, and in order to measure that, you have to know whether you're producing something valuable. So, I mean, continuous integration, like you said, you can have all these unit tests, but until you actually mix it together with something that's somewhat real, larger sets of systems, you really don't know whether it's going to work as a whole. And that's really the key there. And you can't do any of that without automation. So even though continuous integration is a philosophy, you really have to leverage whatever tools you can make available to make that reality. Because the human person, every human trying to continuously integrate is a great theory, but we just make too many mistakes without actually having done something wrong necessarily on purpose. Whereas if you can automate the whole process and make it happen over and over and over again, that's how you can ensure that you're producing what you think you're producing.
Right, and make it consistent from a scientific method perspective instead of having a human, which is who the hell knows what they're going to do. You've got automation, which is auditable and it is predictable and all the good ables or illities or whatever however you want to.
Pick your buzz term.
Exactly. Pick your ending to the terminology. Very good. Yeah. All right. Thank you, Spencer. Vishnu.
Yeah, I think the rest of the team has covered, and obviously you started off with Fowler, I guess. So most of what is talked about continuous integration, I think everybody knows. But what I'm going to touch base is what we have seen, especially coming from a cloud-based technologies perspective. So for most of my clients, for example, CI is something that that is just enabling version control for them. And they have a manual testing team, maybe 3 or 4, and a dev team about 15, and that's all they want to do. And just like, for example, if you have CI, a Facebook might not just want CI, right? They might want continuous deployment or continuous delivery as such. So from my perspective, and the ecosystem and the environment that we work in, so obviously there are key things that CI is required, and obviously from a definition perspective, all is required is I think it's more of a process, number one, which is kind of understood, but it needs to ensure that you have to have a mainline code, and then it's as I said, the fail fast thing in terms of getting your code checked in every day and getting tested. So I think that's the basic bottom line of CI. It's a process. You have a mainline code, do check-ins, and get it tested out for rolling out. So and the basic components of this, number one, would be the tools in terms of the tools that you're using, and the process, and then finally in terms of all automation. For example, from AutoRabbit's perspective, again, just going off a little bit more than what is CI perspective, from our perspective, what we are trying to the vision for AutoRabbit is that anything that our clients are doing, which is taking 15 minutes, and they have to do it more than 3 times, we try to automate it. So that is a vision that we have kept. And I think we are there about 90-95%. The other 5% is two-way tough. It's too expensive for us, but we are getting there pretty quick.
Nice. Yeah, waiting time is the worst kind of time. Ask a 5-year-old when they're waiting for those cookies to come out of the oven. That's the absolute worst, is to have to just sit there and wait when you know that that's so much goodness just right there. Right on. All right, thank you, Vishnu. So I'm not gonna come to you next because you're last, and I'm gonna go to Anders.
Okay.
Anders, have you ever heard of continuous integration?
A couple of times. I think I will define it by kind of what we don't do anymore.
Okay. Can you talk about what you'll do? And that's for Rob. Yeah. But no, let's talk about what you don't do.
It's you know, back in the bad old days. I was talking once to somebody who worked on the Lotus Notes product, and their process was all the engineers would go off on their own for 6 weeks at a time in code. And then after 6 weeks, they would all come back and they would have an integration storm for another 6 weeks, where they would try to make everybody's code work together. So I think CI is sort of the antidote to those sorts of foolishnesses, if that's a word, and really, you know, about making sure that what we're coding works and doesn't break other people's stuff and doesn't keep them from being productive.
I have the
really
those train tracks. You've seen those train tracks, and they come together, but like this, right? That's what I think of when you mention that whole integration swarm thing. That's bound to happen.
Exactly.
Yeah. So nobody's talked really about culture as far as continuous integration. Is it just tools, and you just say, okay, everybody, now we've got the tools, and so now we're doing continuous integration, or is there something else required there?
No, I mean, I think culturally it's about don't prevent other people from getting their work done. And so when it comes to submitting your changes, you need to make sure you don't screw people up. And the CI system is part of doing that. And especially if you do pre-commit CI type things, then you're really pretty sure that you're not going to screw people up. So it's a lot of it is about that and making sure that, I mean, this is the beginning of continuous delivery, right? If you want to be always ready to ship your product, step number 1, it has to build. Step number 2, the tests better pass. Yeah. So it's really the first, you know, kind of the first phase of getting your product out the door. Do it often and make sure things work.
Yeah. And so pre-commit, I'm going to play stupid. What is that?
That's really doing CI on your changes, but before you submit them to the change control system, to the SCM. And so the idea there is basically do what would happen if you were to do a submit right now, and tell you whether it would succeed or not, whether you would break the build or not. It doesn't guarantee 100% that when you submit you're not going to break the build, but it takes away all of the stupid mistakes, that's for sure, and really gives you a lot more confidence that when you submit your changes you're not going to break anything. It's not 100% perfect, nothing can be, but you know, it takes a lot of the oops out of submissions.
So I'm going to just guess, because obviously I don't know, but what I think it does is it takes whatever changes you've made, gets trunked, pulls it down to your local workstation or to some build cloud, and then runs it, because somebody may have changed something while you were making your changes. And so that way...
Yeah, and also depending on what SCM system you use, you may have forgotten to tell the SCM system that you added a file or edited a file, and when you go do that submit, you know, that's going to get left out and you're going to break the build. It worked on my machine syndrome. So really it's geared towards, you know, towards catching all of the stupid mistakes and also some of the more complicated things that we get into in terms of integrating with other people's code.
Excellent. All right. Well, that sounds like a really useful feature. I wish there was something like that for...
If only there was a product that had that feature, right?
Yeah, that would be great. All right, Eric, what are your thoughts on CI? I'm sure a lot of people have said things that you'd like to say also, but...
yeah, so the funny thing is, actually, Anders just scooped me, because I was going to talk about the pre-flight concept. Because it's sort of funny to me about CI, at least the way that my team has done it, is that there's sort of this notion that you've got this build server and you submit your stuff into that and you sort of cross your fingers and hope that it doesn't break. And if it does, that's okay. That's what CI is about, right? And then you find out about it quickly. But in fact, the way we've done CI, because we rely so heavily on those pre-flight builds, is nominally our CI build basically never breaks. So that thing actually is almost not useful to us. What was useful was that was the forcing function for building the infrastructure that allowed us to do pre-flights. And then once we had that, we could impose a culture that said, no, before you do a check-in, you have to do that pre-flight build and make sure it's going to be good. And that basically brought down our integration failures to basically zero, right? Because
so do you guys do your own commits, or does the pre-flight system do the commit on your behalf after it's tested?
So we're using a really old sort of prototype version of the pre-flight concept in our system.
Okay.
So since then, the state of the art has advanced a lot, but because we're a bunch of old stick-in-the-mud programmers who don't like to change, we're still using our old system, which means that we sort of manually shepherd it. Once we see that our pre-flight build has worked, then we do the check-in ourselves.
You do your check-in
But there are more
old school
systems.
With a K.
I suspect, in fact, that our own other product can do the check-in automatically for me if we could only be bothered to upgrade. But
Hunters.
I'm much too busy building new product to do that.
Good. If it ain't broke, don't fix it.
Yes,
That's
exactly.
right. Although if it ain't built, then try and break it. I guess those are the two corollaries. Very good. All right. Does anybody else here, has anyone else on the panel ever heard of this concept of pre-flight? Anyone else doing something like that as part of your CI?
Yeah, so basically we do as a kind of pre-flight kind of stuff. So pre-commit testing and all. So before we check in the specific code base into the main line, like the branch and all, we do the shelving as we use the Perforce as a SCM tool. So we shelve the changes from the other workstation, and then we do kind of pre-flight build and see whether the specific build or whether the specific CI is going to succeed or no. And then probably once everything goes well, then we do the check-in and all that. So that is like we have already done as a kind of pre-commit, pre-flight kind of CI system in place. And that is also on the each developer system. So what happens is that we have an individual development system for per developer, and then what happens is that if someone has to check in the code, then what he does is that like he first of all shelve the changes, okay, and then basically make available for the other guys, okay, and then make the current code base stable along with the other changes, and make sure that all the unit test cases and everything passes and all that along with the code stuff. Once everything goes well, then probably we are like quite sure, okay, that once we check into the master branch or like the central version control system, the build is going to succeed. So that is what we also do as a part of first stuff.
Excellent. Yeah, super helpful
Yeah.
to know when you're about to drive your car into a
Yeah.
building. Not to do that.
Exactly.
A nice thing. Anybody else using something like that?
So yeah,
Yeah. Go ahead.
clearly everybody should be a cultural kind of thing where you're actually trying to check before you commit things into the main line. But another pattern is essentially everybody is just using short-lived branches, assuming your CM system supports easy-to-use branching, and then you use your CI automation tool of choice to go and actually do auto merges across various branches, especially against the main line, and do those permutations that would be annoying for the average developer to do it, but to catch things that wouldn't be caught if there were people not basically sharing their work in a place that everybody could easily grasp it. So sometimes it gives you false positives, but really it's a good indicator that, hey, if everything's building well, it's going to build well when I actually push it up for real.
So
Or merge
Spencer,
in, essentially.
That's not a pattern that we've had to adopt, and I'm curious, is it your experience that that's something that you need once you get to a bigger team size? Is that related to the scale of the project that you're working on?
This would be where you've got 7, 8, 9 people all banging on things where they're crossing over tens or dozens of classes and doing completely different capabilities simultaneously. So yes, it doesn't matter on a really small team, but even a small team could have that happen, but it's rare. The bigger the team, the greater the likelihood of the overlap of feature collision where you're actually trying to add orthogonal features that shouldn't have any impacts, but if you do any refactoring while you're doing it, you want to move up the time when you have a discovery of, oh, that's no longer called that, or you moved it over here in a completely different class. You really want to get everybody's changes
signature.
out there. You want them out there visible. They may not be in the trunk, but they're out there in the branches, and they're already automatically being compared by the CI system so that you can just kind of alert everybody early, hey, somebody made a change that breaks somebody else's working branch. And then, by the end of your sprint, you cycle everything in. But it's surprising on a larger team on certain times. I mean, very often it doesn't matter, but when it does, it's early. It's every day kind of counts. Every hour counts sometimes.
Time is valuable. That's the only thing that you can't buy more of that I'm told.
Well, either that or your family hates you.
That's right. That's right. So that's great. So let's move on, and I think we're sort of starting to get into this already a little bit. Let's talk about some of the tips and the tricks that you guys are using to keep your builds speedy for your users. So what does that look like? Oh, look at that. I'm on the wrong slide. I don't know why that's not happening. Oh, well. So you can see my slide. The correct slide is up now. Oh, that's right. I didn't make a PDF of this thing. That's the problem. That's okay. You guys they're telling me, everyone in the room here is telling me, okay, move on, move on. Can you do the move on signal again? Okay, thank you. All right, now everybody knows. So builds and tests. Let's start with Vishnu. Let's start with you and tell me a little bit about the code base you're using. What is your how many developers, and then what does your build time look like, and how have you worked on incrementally making that better, continually making it better?
Sure. Again, our code base is not that big, but I will take several examples that we have done with our clients, and some of them obviously not from AutoRabbit internal tools perspective, but how we help our clients get there. For example, one of the key things is testing is something that.
So we've got a whole slide on testing.
No, I know. So I was coming to that. So testing is something that a lot of times do not even want to talk about it. But coming to builds, what typically we have seen is it runs anywhere from about 5 minutes mostly, a lot of times, to all the way up to maybe 2 to 3 hours. And in a Java world, that might be a lot of variance. But in Salesforce world, 3 hours is unimaginable because it's typically cloud-based, and developers are kind of keying away their things. And the other things is it's a little bit more pertinent in this particular model, especially in the Salesforce ecosystem, is because typically a developer would spend about 30% of his time managing his code, always. So in terms of builds, what typically is that, again, the code base might not be because of the restrictions of cloud technology or sandboxes, for example. There are a lot of impedances in terms of the governor limits, meaning that you can only access the sandbox for X amount of time. So it times out at about 60 minutes or maybe 2 hours or nothing more than that. Every time after 2 hours, you have to kind of break the builds into several different things. So there's extensive amount of scripting that goes on, which is kind of a challenge that we are solving for our clients.
Oh wow! So that as these things organically change, because obviously you're innovating and you're adding code or you're refactoring and moving things around, you have to constantly be aware that you can start some job up, but that machine that the job is running on will just be killed after an hour arbitrarily. And if you're in the middle of something, tough luck.
Not just killing from a timeout session perspective, but you will have all these other limits in terms of total amount of data that can go through. So some of these high-end infrastructure or sandboxes, as they're called, on servers on the cloud, they are very, very expensive. So typically, the low end would mean that you have got additional issues or additional constraints like the total amount of data that even if you would want to kind of get some sample UAT data in place, it kind of cuts down at 50 MB, which is kind of really, really low. So And then you would have to do a separate data load to get the latest and the greatest data, even the sample data, even that gets cut out. And then so-called queries or queries that you write, even those are pretty limited. So you cannot have like you cannot have a wish list of things that will kind of get done. Everything is kind of curtailed. So you have to kind of operate on this very specific, tiny window of opportunity that you have a lot of times, especially obviously taking out the maintenance windows and things like that, wherein your release team is working on them, and then again especially with the different instances that you have, everybody tries to move from one stage to another, and the parallel builds are happening, and that's where kind of things kind of really break down. So essentially, it's a little bit more simplistic in the nature of the time, in the amount of data and amount of the size of the builds, but the complexity is in terms of the parameters that we have to kind of constantly work around the day in and day out.
Nice. Okay, very interesting. Thank you. Spencer, build-related tips and tricks. What are you guys using to keep your builds fast? First, what are you building? It sounds like you're building some Java, from what I gathered.
So I build various different things. So I've built and presently build. So in the past, mixed build, C++, Java, C. Now it's more Java, helping people out with those kinds of things. But I probably mentioned at one point that I use a tool like Gradle. Should be using something at least like Maven. Ideally, there's this notion of, well, the build should be fast. Well, that's great, but that's a clean build. What is it when I make one little change? How many ripple effects do I have? Lots of build tools, if you're not careful, you make a change and everything recompiles, everything rebuilds an artifact downstream, and it triggers. You have to be really careful to try and get either your CI system or your build tool itself. Hopefully you have one that can help partition those off. I remember the old school builds of C++ when templates came in, and yeah, hour-long builds were not uncommon, and that was spreading them out on multiple machines. So things are better in technology now, but it comes down to how quick can you make it so the developer doesn't go, I don't want to make all these changes. I'm going to make all of them at once because I know the build's going to take too long.
Right. And I'll do it right before I go home. Yeah.
So really the trick is focusing with somebody who pretends or really is a build master and try to get your builds to function properly, because the payback is immense. It's amazing how much, if you can shave off 30 seconds, a minute off from any kind of build. You're talking about huge, like hours to minutes. Even for a regular dev during the day, you start shaving off a few minutes here and there, and it makes a big difference in the cycle time.
Yeah, absolutely. So you talked a little bit about something related to this, but not specifically about dependencies. So you talked about the ripple effect of things that need to be rebuilt. So
you want me to talk about, right, so you're generating artifacts of some sort, and you should be storing those and reusing them throughout your pipeline. We haven't talked about pipelining yet, but definitely when you're doing CI, you never want to rebuild the same item unless you absolutely have to at some later point in time, and then use that throughout the different chains throughout your builds. And then we'll talk about testing later, because that's where you often use a lot of these generated artifacts.
Right.
And then if you've already got it pre-built, grab it, reuse it, and go. It's only when you've actually got a version change that you know that you should have to have any compilation occurring.
Yep.
And that's not true of lots of systems, but it's getting more true because people are starting to use the contemporary tools and make it's not uncommon for everybody to have their own Artifactory or Sonatype Nexus server to contain that and to publish to it. I mean, it used to be considered wow, but now it's the norm, and it should be. Absolutely should be. And then your CI, whatever it is, should be able to pull from it as necessary, or leverage your build tool. They should be cooperative of some sort.
Yep. Very good. Thanks, Spencer. Nirav, what are your thoughts on build times and tips and tricks for keeping the build fast?
Sure. So we have been largely working on Java and Groovy, and majority of our projects are built with Java or Groovy as a language, and probably Spring or Grails as a web development framework. So for us, it is not only the quick build time, because the average project size for us is 2,000 Java files to probably 4,500 Java Groovy files. So when we have a lot of lines of code that is written, it's important for us to build, but it is also important for us to have a clean code that we have written. So say for instance, if we keep on code and if we keep on mounting the steady code that we have written, or are having a lot of steady code analysis warnings that is being generated from say PMD or find bugs, then there is a lot of pressure for us to clear the technical debt in the sprint that we'll be having in the next probably quarter. So towards the end of every sprint, we have a retrospection and we keep on checking against the how many number of builds that has failed and how many of steady code analysis warnings that we have X to sprint X plus 1. So we keep on comparing these two things and we try and leverage our processes in a way that one, we wanted to have building faster, and two, we wanted to have this technical debts getting reduced time on time. So in order to fix or in order to have a trade-off between these two things, we have a couple of things. One is environment specific every developer machine. So for instance, if it is Grails as a framework, then we have environment set up for each and every developer. So if I'm working, I would be having my local copy of database, my local copy of properties and configuration files. Everything would be local to me. So before I can anything to the central repo, I'll be creating a build, I'll be checking it against the steady code analysis, and then only I'll be allowed to commit the change. So one is that. Second tip for us is to have a tightly integrated or STS profiles. So even if I'm making some mistakes while I'm coding something, even if it is not a compile time error, but a requirement from the compliance, like this is how I should be naming something, this is how I should be putting comments, this is how I should be putting some other marks, then I'll be catching them right at the developer's machine. So this is what we allow our developers to move forward as a part of the process, and that will prevent us the rework, which is the gain that we have made by allowing processes and compliance against the build. So building
static code analysis is part of your build step. Is that a common thing?
Yes, because if we do not do that, that will keep on mounting. And for a larger project, and especially if it is in maintenance, like say marketing team or the client will never allow completing those technical debts, and essentially will end up doing say code for today and not for tomorrow. So somebody else will have to do that for us, and probably it's not done anytime. So my code would be becoming legacy sooner than required. So that's the objective for us. So we try and build our projects in a way that say if it's a project for me in Grails, and if there are say 14 modules, we try and pack them up in a smaller Maven projects. So at a time only one project would be triggered and would be checked in back to the main repository, and it would be triggered on CI tool. So we try and keep the modules in a smaller way, and we try and release it to the CI server because they are smaller in nature, and that will allow us giving again a quick feedback loop and allow developers to check in more rapidly. So that is the process we have been following, and to the quite extent we are good about that.
So separation of concerns, including the static analysis earlier in the cycle to get that feedback for your teams. That of course brings the separation of concerns and that splitting of your components into multiple things that obviously will affect maybe your testing later on, and we can talk a little bit more about that on the next slide.
Yes, absolutely. There is an end-to-end strategy defined. So absolutely, testing and automation is a vital part about that. And yes, I'll be talking on that in the next question. Yeah.
Perfect. All right, Nirav, thanks. Irfan, what are your thoughts on build times and keeping them nice and quick?
Yeah. So on those lines, basically, I have a few tips and tricks, basically how to make this and all. So first of all is like the infrastructure. Okay, so whatever the build infrastructure which we have, so as a part of the CI process, what we have done is like we make sure that the infrastructure on which we are going to build, it should be clean and minimal. So we stop all the backdoor entries and we make sure that it is very uh, it should contain the required libraries and files rather than having a number of things installed on those stuff and all. So build slaves, it should be only required thing should be there on that front, and it should be every time spawnable. So it is not just like a once we make the build infrastructure and then probably we keep on building the packages on the same box, and then we keep on releasing from the same box and all that. So the thing is like to just to maintain the speed up and all that, make sure that our build infrastructure is very clean and we have all the necessary files on that specific box, and remove all the unnecessary libraries and stuff. Everything is defined on that box should be from some kind of version control system, and make sure that the infrastructure is really up to the mark and stuff. Second thing, as a part of speedy process is like unit test cases. Most of the time, what happens is that development team, they write the unit test cases, and then as a part of CI process, we keep on executing those unit test cases as a sequential stuff. So try to make the unit test cases more as a parallel. So whenever the unit test cases are there, execute them in a more parallel manner rather than in a sequential manner. So okay, so that will reduce the build time and then make our system more quickly releasable and all those stuff. So here the idea is like whenever we build as a part of a CI process, we consider every artifact as a releasable artifact. It is not just a kind of a snapshot artifact or some kind of a developer artifact and all. So as a part of a mindset, what we have, what we are trying to achieve is like whenever we build the artifact, it should be in a releasable format. So as of now, we are using Java Spring Boot technology for all our application and all. We have Java as a 90% tools and technology front, and that is what as of now we are using. So what we try to make is like every candidate which we are every artifact which we are building should be releasable. I mean, it should not contain that okay, this specific artifact which we have generated is now need to go to some other quality gates or something like that. Whatever static code analysis, whatever stuff we need to do, we need to complete in a specific time period and get everything done, and then make sure that we have passed all the quality gates. Certain other parts is like what we are trying to achieve is like the containerization. So as a part of a CI process, we have given environment to the development team that they can build their own artifact onto the container, like a Docker-based container. So we have used Docker, and we have given them as the images, like a dev images. So that Docker image which contains only the required libraries, and for every CI build, we deploy that specific artifact on that Docker image, and then make it available for the dev testing purpose. So that leverage development team to work on isolation and see that okay, whatever testing is to be done should be in a specific format, and then they are not blocked onto the central CI system or something like that. So that is another way of having a development team or a specific developer to work on a specific area, and they should not depend on anything. But the thing is like we are not promoting any kind of isolation, but what we are trying to achieve is like whenever we are done, when the definition of done a specific story or a task and all, make the check-in immediately as early as possible, and make the specific change available to the rest of the team. So that is one thing what we have done. Other thing other thing we have tried to achieve is like infrastructure as a code. So as we are using Jenkins for a CI pipeline, so what we are trying to achieve here is like whatever configuration part is there from the Jenkins, that all store into our central code repository system. So we are using Perforce, and we have checked in everything from the CI perspective. So our Jenkins master server and the Jenkins slaves and all that, they get spawned also on a specific time by reading our DevOps tool, and then every Jenkins entire infrastructure is gets created from the config parameter and the config files, which is stored onto the central repository. That gives you another level of confidence that okay, whenever I have a CI system in place, that is not like a static. That is like a fully software-defined kind of system where all the config parameters are checked into the code base, and then developers have full privilege or full control on each and every config parameter which they want to modify into the Jenkins and go ahead. So they do not need to dependent on the DevOps team or probably a kind of a release team that okay, I need to make one change. Can you please do that? And then go ahead from that point. So it is like for us is like everything as a code. So we are not saying that okay, Jenkins is just a kind of a CI tool and it is just a kind of a config. So for us, Chef or Puppet or whatever is the case, we are like entire as a code base and not the config. And the last point,
you will be able to refactor that pipeline the same way you refactor your application. If you can't get your code in production, then there's really no point in writing any of that code. That's great, Irfan. Thank you.
Exactly.
Eric, I've heard a lot of people talking about sort of making sure that all the tools are on the right things in the right places and sort of virtualizing that tool chain. What are your thoughts around how do you make builds faster? I know there's one big answer that you'll give, but
so let me answer your question with a question.
Okay.
Are we talking about build, big B build, as in the entire process from checkout through compile through test through packaging? Or are we talking about build, little b build, just the compile part?
Whatever you'd like to answer.
Okay. So obviously my whole reason for existence in the last 15 years has been making a build accelerator, which is on the specifically the compile part of that, right? Actually, our own build is about 30 minutes if we don't use our tool to build it, and it's a little bit less than 1 minute when we do. And we achieve that by distributing the build out to a cluster of computers and by using build avoidance or object reuse technologies in order to achieve that. And on top of that, it's sort of implicit in the way that we've set things up, but we've got sort of the concept of componentization that some other people have mentioned. That's absolutely critical. You don't want to have to be rebuilding everything all the time. I think when you're talking about C++ code, it's a little bit of a more nebulous concept than it has been enshrined in the Java ecosystem now. With Maven and artifacts and things like that, it's a very, very strong concept there. But even in C++, right, I'm not actually rebuilding my compiler from scratch every time that I build my code, right? I'm not rebuilding.
Although I wouldn't put it past him.
I mean, we certainly could, right? We could start from absolutely zero and build all the way up, but that would be insane. Nobody would actually do that. And so in that sense, we do have that sort of notion of componentization and avoiding rebuilding stuff that's not actually changed in any meaningful way. Now, beyond that, if you're talking about the entire process, right, the key things to me still are parallelization and distribution, right? So we actually orchestrate the entire our entire process, our whole CI process across an enormous set of machines. I think we've got that's got to be about 45 machines that get involved once you count all the machines we use for compiling and all the machines we use for testing, and that all happens in parallel, right? And that is absolutely critical. And even with that, our whole process is still a lot longer than we'd like it to be. And what I have found,
can a process ever be too fast? Can a cycle ever be too fast? The answer is no.
So if we're talking about development, then the answer is no. Yeah, there's lots of processes in life that I wish we could quite so fast.
Longer. Okay, we'll leave that one go.
That's Jack where I was going there.
Mm-hmm.
So we coordinate that across a whole bunch of machines. And it's all about parallelization still. And
45 machines.
45 machines.
Lots of
I really
tools.
did completely forget where I was going with that.
Yeah, dependency management problems. You got an object linking problem. Nice.
So I guess I'll leave it there. I'll wait until we come back to something else that jogs my memory.
I'm sorry, I was trying to be funny, and apparently I just totally messed up your whole shtick. So I'll ask Anders to comment on this, and then if Eric remembers what he was thinking of the brain fart. What happens when you get old? I'm not calling you old, but I'm not calling you young either. So Anders.
It's my birthday tomorrow, actually.
Oh, happy birthday.
Ooh.
Great.
Happy almost birthday. So it's interesting because our challenge with building our own product is tests. And so what we've had to do over the years is kind of segregate our tests into several phases, so that we basically run multiple phases of CI. You do a submit, and we kick off basically a unit test only build that does a kind of a minimal build based on what you checked in. So we use what little dependency information we can glean from it's largely a Java build at this point. So we glean what little dependency information we can from Maven, which isn't much, and kind of try to minimize the build that way. So if you're making a change in one of the kind of leaf areas of the product, your CI build should be just a few minutes, 5 minutes or less. If you go change something in a core library or something like that, then the cascaded CI might be more closer to 15 or 25 minutes. And then there's a follow-up which does integration tests and system tests and builds installers and does upgrade tests and all of this other stuff, which if we laid it all end to end would probably take close to 24 hours by the time everything is said and done. But because we use Accelerator and Flow to accelerate all of these things, we end up doing a full platform. Like if we were to do our end-to-end most accelerated, fastest platform build, it's on the order of 4 hours, to build all the installers and go do all the upgrade tests and all of that stuff. So obviously we've spent some time kind of slicing this up so that engineers get the fastest amount of feedback we can get. But it could always be faster, except for those things which are slower.
Right, like birthdays. So you remember what you were talking about, tool virtualization?
Yes, right. So there's two things there actually. So one of the things I was going to say is that what I have found fantastically helpful in making my build process faster is to visualize the process, right? So we actually built a plugin for Electric Commander that allows us to graphically see exactly where the time is going, and this has been tremendously useful in knowing where I, as the architect of that process, should be focusing my effort, right?
The long pole.
Exactly, right. And we've actually had some pretty heated conversations in my team where people have sworn, up and down, no, I'm certain that this is the thing that's slow. And I said, well, look, here's the picture.
Here's the data.
It's not actually that thing. And I can make that thing 10 times faster. It's not going to matter. Right. So it's absolutely critical to have that kind of insight and visualization of your process so that you know where to spend your time. As far as the tool virtualization thing, so I thought what Irfan was saying was kind of interesting there, that they kind of put a lot of effort into setting their systems up to be reproducible. I'm a little surprised that more people on this panel actually aren't using or didn't mention using containers or Docker and things like that, because that's sort of what that's all about, right? Making your environment reproducible. Or Vagrant or Chef or Puppet, things like that, right? So that stuff is all really important. Although, to my mind, that I don't think of that as necessarily part of making the build fast, right? That's about making your system reliable or reproducible, right? Which is also very important, and that's sort of it's a little bit hard to talk about one thing without also talking about the other one. So we get these things all tangled together in these conversations.
Yeah. One of the other interesting things about sort of the whole Docker thing is the idea of chroot, right? We have a lot of customers that are they're targeting multiple platforms with whatever they're building. So they have to build it against a different set of libraries. Emulex is one of these customers. Ericsson is one of these customers. And they are actually using, you're going to correct me because I'm probably going to butcher this, but they're using a Linux kernel, 2.6 or whatever version they care about, and then they're creating a chroot with all the libraries that are needed to build for Ubuntu or to build for Red Hat. And it allows them to use a common build infrastructure and target multiple different flavors of operating systems as an output, which again gives them a ton of flexibility. It allows them to take more advantage of the resources that they already have without waiting for someone to tear down an entire Linux container and pull it back up, and without having to worry about virtualization, the overhead. Did I say that correctly?
It was actually perfect, except that you got the Linux kernel version wrong. But other than that, it was fine.
Okay, well, good. What version are we on with the Linux kernel?
The latest is, I think, 4.2.
Oh boy.
4.
Yikes! Yeah.
The containers showed up sometime in the 3.x. 2.7 is like.
Oh, okay. Well, sorry about that.
But it's okay.
Okay. Very good. Anders, you went already? I don't know why I'm going back to you.
I mean, I can blather on for more time, but
No, because we have 10 minutes left, and so people have already talked a little bit about testing. We have 10 minutes left. This has been a much more interesting conversation than I had given it initial credit for. You guys have a lot of interesting things to say. So now the next sort of topic here is tips and tricks for testing. Who would like to start? I'm going to take a show of hands. Who would like to talk about testing? Eric would. I'm going to let Eric go first because he never wants to go first.
All right, I'll be quick. So Anders already mentioned this a little bit. The idea that you want to split up your testing into sort of the fast stuff and the slow stuff. I'll definitely second that. We've done something along those lines in our own builds. We've actually even gone as far as to say we did a complete audit of all of our tests, which again involved some visualization tools and some instrumentation that we wrote custom for the purpose, to say what are the really slow tests. And we found that out of our whatever 10 or 15,000 tests, there was like 50 tests that were really, really slow. And we just said, you know what, we're not actually getting that much value out of running those tests all the time. So we just turned them off, and we went and we filed tickets in our bug tracker to remind ourselves to come back and find a better way to write those in the future. I think sometimes people say, oh, it's a test, I can't have less tests. I can't have less tests, but that's not true, right? You have to weigh the value that you get out of running those tests against the cost of running those tests. And sometimes the answer really is there's not enough value there to justify doing that particular test.
Right.
So then you do that, and then you can refactor your test suites that you have the stuff that you run on every single check-in, and maybe another set of stuff that takes a little bit longer that you can run a little bit less frequently. Obviously, the best thing is if you can run everything all the time, but that's not always realistic.
Yeah, or the best thing is if you can just run the ones that are going to have some change.
So if you're very diligent and very clever and have very good tooling, then you can do stuff like that, where you can know, okay, when I change this source file, these are the sets of tests
trickle down,
matter, right? Mm-hmm. Probably everybody on this panel has heard about how Google does that in their internal system. My experience with that is that's a great ideal to strive for, but it's very hard to achieve because the tooling is just not really there to make that easy. Yeah. So certainly not in the C++ ecosystem. In Java, maybe, because there's a much greater amount of introspection that you can do on the generated code. But even then, it's not great. So there are some tricks you can do, right? So like Maven has their Surefire, I think is the plugin there to do the reordering tests, so that the stuff that changes is more likely to run.
And then how do you test that process, right? You have to test your test process. There's some opacity there.
Right.
It's sort of a black box.
It's like turtles all the way down, right? So,
exactly.
So if you can do that, then that's awesome. But I wouldn't necessarily look down on somebody for not having that set up, because it is very difficult. And again, it's all about the cost benefit. Right?
And so before I let you go, so does parallelization, does that help at all? So with the gross parallelization,
it does. So absolutely, you can do gross parallelization. That's the kind of thing that we've done with Electric Commander, Electric Flow, where we say, look, this batch of tests is going to run on this machine, this batch on this machine. Fine-grained parallelism is also can be fantastically useful. That's an approach that we're starting to encourage our customers to explore with Electric Accelerator now, where we can automatically break up a big test suite into its individual test pieces and run those all in parallel on a cluster of machines.
Yeah.
If that's something you can do, then that is awesome. It's fantastic. That can be like a night and day difference in how fast your tests take.
Yeah, with a lot of the modern languages, the builds, a 5-minute build.
Right.
Accelerating that may not be as interesting, but if you have a 60-minute Selenium suite that needs to run, and you can do that in a minute, which we've had people who do, that's for you again, Rob. That's interesting, right? Anyone else have anything they want to talk about with testing? Anders? No? Nirav?
Yeah.
Go for it.
So it's a part of we have headless testing that I would recommend definitely. Like if it is a UI-based application and we would like to go for some browser-based testing, like we have the headless testing offered, and there are plenty of drivers available which can allow you performing doing this kind of activity. So that is one. Second, on the lines that Eric mentioned, that instead of focusing on tests that is executing faster and a few that is executing slower, probably I would vote on a strategy which allows the RBT, that is so if I know that if I have say 500 scenarios and 100 of them are probably having the highest business severity, then I'll focus on executing test first while I'm releasing some patches or some hot fixes, and I'll not be bothering on executing 400 rest of the test cases wherein the severity is probably say medium or low. So I've been marking each of my test cases with the scale of say severity 0 to 10, and the highest priority or highest severity cases or scenarios would be executed all the time while I'm releasing even any of the patch. So that would allow me releasing my builds faster because then majority of my risk would be covered even if I'm releasing quite rapidly. The third would be obviously going for some grids, say for instance, Selenium-based grid, or all of these concepts are already built with the physical testing as well. So we can leverage the grids, and we can allow regression sheets to be performed over multiple OS and multiple browsers, making sure that none of the UI test actually is probably failing at any of the browser, especially probably IE, and then we can take care of them.
Yeah, IE is the one of the slowest on that. They don't. It's not very good at sharing that engine.
Yeah.
So,
Yeah.
And probably the last thing is segregating these sheets based on say UI, APIs, and databases. So if we can segregate out our based on the software architecture layers, then probably it can help us fixing and identifying issues even faster, and probably we can have a better feedback channel. So this in a nutshell, I can think that can help us providing automation strategy.
Very good. Thanks, Nirav. Vishnu, you had something? We have 3 minutes left. So final thoughts.
I had a ton of things to say, but anyway, so just adding on top of what Eric and Nirav was saying, obviously all this parallelization and things are good, but just to kind of really give a quick short summary, one is get more budgets. Obviously, ROI planning is very important, so that's what managers need to absolutely do always. So even if you want new servers or something like that, you always got to be there on the job. So number one. And then in terms of there are small tips and tricks that we have used. For example, what we do is it's more of a voting kind of a thing for each test case. We divide them between gold, silver, and bronze. So everybody, when test case comes in, they kind of say, hey, this is the gold or this is the bronze. And sometimes if it's not even voted, you know where it goes. It goes directly into the trash bin kind of a thing. So no vote does. It's just that it's not used ever, mostly. And on top of that, what we have done is obviously break it down into large or small test cases do not matter. It's dependent upon the weightage, right? So finally, at the end of the day, it's about weightage in terms of the infrastructure that we have and how fast that we need to do. And then finally, again, just going back 1 second a bit, was from the build management process also, what we did was, one of the key things is to have a build management strategy that you kind of are looking at every given point in time. And similarly, that is where, again, it's a process, it's an evolving document, and same thing with the testing also. So especially the manager, the leader should have a test planning strategy in terms of what his budgets are coming in, how much infrastructure can we use, what new processes and new tools that he can get. And obviously, they need to understand that every new process that you're getting in, it's a 2-month exercise or a 3-month exercise mostly. And the last but not the least is test analytics. So we do not really have to do all these things manually in terms of providing gold, silver, bronze, and all these things. Right now, there are a lot of tools, and you can write your own analytics in terms of how the system. So we use the random forest algorithms and a couple of algorithms that have been fine-tuned by our data scientists. So essentially, what it does is the algorithm itself are able to predict in terms of which test cases are able to kind of figure out which modules. So every test case does not need to kind of go to every module. So as long as the test cases are recorded, the algorithm obviously figures out which module, if a specific module has been changed, the build has been there, the appropriate test cases are triggered instead of all the test cases. So analytics is very, very mature. That is something that not every company is kind of leveraging it. I think there's a great potential there.
Right. Great. All right, Spencer. Final minute. Final thought.
Really quick. Yeah, really quick there. We've got the separations in the unit, integration, acceptance tests. Essentially, your unit tests should be so fast, you should break the build if they're not fast enough. Literally. Make your devs not do I/O access, all these other things. They're supposed to be focusing on those classes, and it makes a big impact if you make sure that your devs are running the unit test every single compile. It should be considered part of the compile. That's all I wanted to add.
Great. Spencer, thank you so much. Irfan, final thoughts, 30 seconds.
Yeah, so on those lines, basically we have TDT implemented, test-driven development, and then probably from that perspective also we have everything automated, and then so our main intention is to have most of the test cases automated and make sure that we have more parallelization achieved. In our case, the specific point which I would like to bring here is like the milestone-specific test cases which we have, and then we try to make a single platform and a framework so that all the test cases can be achieved, and that also depends on the module and the release cycle. And none of the test cases should be repeatable or like a redundancy and all that, so that we should not waste our time in testing same test cases again and again with no value add. So that is what we make sure that everything is consistent and make sure that across the platform. So that is what
Great.
I would like to include.
Thank you, Irfan. That's wonderful. Anders, unless, Eric, you have anything you want to know? Okay, Anders, bring us home, baby.
I think there's a lot of great ideas there. I think focus on the speed of your CI cycles. It's incredibly important to get them down. It's worth a lot of effort. It's worth money. It's worth putting your best people on. Don't put your new green junior engineers on these kinds of problems, because they're much more important than that. I think that's where I would leave off.
I love it. All right, guys. Thanks, everybody, for joining. We're helping to figure out how to turn your CI cycles from a chore into a competitive advantage by going a lot faster. Some cycle times are worth shrinking. Some, as birthdays are concerned, would be nicer if they were a little longer. But that's another product that we'll maybe try and work on. Thanks, everybody.
Thank you.
Bye.
Thanks. Thanks all.
Bye.
Bye-bye.
Everybody.
Bye.